So I will be talking about insulators. Or dielectrics in this lecture. Now we will first start with static fields. Now two parallel plate capacitors of area A, two parallel plates of area A and separation D, if they are charged, one is positively charged, another one is negatively charged, and the space between the plates is evacuated. So space between is evacuated, and if D is much less than the A, or I should say the plate dimension, so there will be a homogeneous electric field between the plates. So it will cause an homogeneous electric field between the plates, and the field strength is given as, we call it as vac because it is a vacuum. It's equal to 4 pi q. Q is the charge on other plates, and it is equal to what we will call D, or D is the electric displacement or flux density. Now, the potential difference between the plates will be given as 5 vac is equal to, evac to D, and the capacitance Cvac which will be equal to A into Q divided by 5 vac. Now in this case we assume in the first case that there is vacuum. Now what we will do, we will fill up the space between the plates and fill it up with say dielectric medium. Even the plates has been filled up by a dielectric medium, so we'll call it an insulator. Now so the new potential is less than the previous one in the case of vacuum, and the capacitance which is inversely proportional to phi, is greater than C vac. So the dielectric constant, or I should say the static dielectric constant epsilon s be the ratio between phi vac and phi, or it can be also the ratio between C and C vac. And as a result of introducing a dielectric inside the two plates, the field strength is now reduced. So E vac, so the new field strength is E, and E vac is actually equal to epsilon S into E. So the field has been reduced by a factor of the dielectric constant. So the effective surface charge Q dash, which is the effective surface charge is now E by 4 pi so the change in the surface charge Q minus Q dash is simply equal to E vac divided by 4 pi into 1 minus 1 by epsilon s, and we will call this quantity as equal to P, and we will write it as again equal to epsilon s minus 1 into E by 4 pi. Thus, under the influence of an external field, the dielectric facing positive plate acquires a negative induced surface charge density P, and vice versa. So we call it, when an electric field is applied, which is external, then the dielectric facing the positive plate acquires negative charge, and vice versa. That means the dielectric facing the negative plate acquires the positive charge. So a sort of polarization is taking place. So this brief vector is actually the polarization vector. So it looks something like this. So if we have a positive plate and you have a negative plate, and you have introduced dielectric between them, Let's put it in this fashion. So this, and you are now applying electric field E. So what happens is that here there will be negative charge and here there will be positive charge. And as we have already told you, there will be a polarization vector P, and displacement vector D will be equal to electric field applied plus 4I into the polarization vector, and it will be again equal to epsilon S E. Now in molecules, although for a system of elementary charges E located at endpoints of a set of vectors, dipole moment M is simply EI RI, and for neutral systems EI is equal to 0. So that makes M induced dipole moment independent of the origin. Now whenever we are applying a electric field to a molecule, we know that so for example a free atom, we'll consider molecules later. In a free atom, the construction is there is a positive nucleus surrounded by an electron cloud. Okay, so whenever we are applying an electric field, it will cause some induced dipole moment, so there will be some polarization taking place here also. So it will shift here, positive and negative charges will cause a shift, and this induced moment is simply equal to alpha E into E, where this substance is called the electronic polarizability of the molecule. Now, apart from this, we have something called an orientational polarization. is usually observed in gases, which has a large number of identical molecules. And the external electric field it actually exerts a torque, and it tends to align the dipoles in the direction of the field. Torque tends to align the dipoles in the direction of the field. So this is the field, this is the dipole, and this is how field is applied. So it will cause a torque so that this one actually starts to get aligned like this. Okay, so this theta angle will change. And so the potential energy, if mu is the mu into E mu dot dipole moment in the electric field will be the potential energy, and it will be given as minus mu E cos theta now the probability of a dipole to make an angle theta and theta plus E theta is proportional to, so go to the next slide. Probability of a dipole to make an angle between theta and theta plus d theta with the proportional to 2 pi sine theta d theta exponential mu e cos theta by kt. Now this 2 pi sine theta, this quantity is actually a solid angle. Between theta and theta plus d theta. And the average component of the dipole moment along the field direction. So the next slide. Average component of dipole moment along the full direction is mu average of cos theta, and which is actually, now this is equal to Langevin function called LA. Langevin function, and it has the following structure. So if we plot LA with respect to A, where A is mu E by KT, then the plot actually looks something like this. And this is 1/3 A, and this value is 0.5, and this value is 1.0. So for a very large value of A, that is for high electric field, the function approaches the saturation value, unity. Okay, that is what has been formed here. So for very large values of A, when A is mu E by KT, that is high field strengths, LA approaches unity, and mu cos theta is equal to mu. So basically, approaching unity means attains saturation. And it means that complete indicates complete alignment of all the dipoles have taken place. However, if the field strength is less, if E is less than 1, that is mu E less than KT, then the value of LA becomes equal to 1/3 A, and mu cos theta is equal to mu into 1/3 A, so it's mu into 1/3 mu E by kt, so that makes it mu square by 3 kt.